Hello everyone, this is Hossein and this is a tutorial video for Siemens NX manufacturing with a focus on lathe machining or turning. The objective of this video is an exercise session or showing you the tutorial, a step-by-step approach to set up the required settings for the initiating the process, defining the main programs and different operation in lathe machining, all the way to the output. I will first show some slides, and then after that, I will go to the latest version of the Siemens NX, and I try to implement these ones, hoping that there would be some errors, and then we see that how to solve those problems. If not, then I will just show you where are the options and menus, how does that work. So in Siemens NX, for turning or lathe machining, we have these three main steps. We need to first define the steps, then main program, and then taking the output from the software. In the first part, the setup, we need to first normally analyze what is the part that we are going to work with. This entails, for example, measuring the size of the parts in case we don't have it already, the diameter, length of the part, and also deciding about the raw stock material in case we need to creating it, or from the workshop floor if there are any diameters we need to have, or sometimes there are not always these cylindrical parts, so that they are somehow halfway machined during some process, for example. So we need to measure those parts and be ready to define in the machine itself. Furthermore, we need to create different type of geometries. So for example, we need to define where is the part, where is the stocks, but also where is the location of the chalk so that we can avoid having any collision, any undesired collision between the tools and the chalk itself. So here you can see how the tutorial is mentioned about how to make the part, or let's say the stock in transparent mode so that you can actually see the part itself. And on the right side, you can see how to choose the setup, to choose the manufacturing in terms of millimeters as a unit, and so on. And I will a little bit also explain you in the software where are the different menus, because this is something that quite often it might be a bit confusing for the students. Next, we should define the correct coordinate system. And if you are failing to define the correct coordinate system, normally we are not able to follow even the next steps. And even if we are able to follow the next step, at the end, we are not able to create any machining process. So after that, our process will be stopped. So pay a bit more attention here to check that if the coordinate systems are correct or not. This is more important. This has become more and more important if you are creating your CAD model in a different orientations, or for example, with the commands except and revolution. So when we are using the revolute, normally the access is going to be automatically considered. So the software consider that one and there wouldn't be any problem normally. But if you are creating your shaft with this extrude and you are taking the modification from a different commands, this is something that you should be also paying attention. That, for example, the x-axis of the coordinate of the x-axis of the component would be basically the same and then here. So you can see that the x-axis of the component here is the same than the z-axis of the machine. So this is an extra important things that you need to pay attention. Of course, in the software, you would be able to modify it, but this needs a little bit more attention, as I said earlier. After that, we have defined this one, we go to define the geometry. At this step, the objective is to define to the software what is the geometry or the desired final geometry we are looking for, as you can see on the left-hand side, and what is the raw stock material. There are two options into specifying the blank or raw stock. Either you have predefined that one, or let's say in the CAD modeling, you have also superposed two components on top of each other. One of them is your final component, as it is shown in the yellow and the in the left hand side of the picture. And also you superpose another component, like for example in the assembly, that is define your raw stock. So here is just a simple cylindric, but of course it can be any random shape, any shape that is actually available in the workshop that you're going to use. This is one option. So you are defining these two geometry superposed on top of each other or inside out of each other in the CAD file, in the assembly file, and you save it. So of course you need to first make one of them transparent to be able to work with the whole piece, and then you are defining what is the work piece, what is the material, and then what is the blank or raw material. Another option is that in case we are only facing with the simple raw stock geometry, like for example, also in this case, only a normal cylinder, in those cases, we can already directly define the raw stock in the software. So this is something that I'm going to do in the software. And after that, we have the avoidance that we can define, and also the chalk that we should be defining. In the next step, to be able to easily work with the different views and how to define, especially when it comes to the internal part of the component that it needs to be machined, the software is actually suggesting to use this kind of a static wireframe that you can see in the pictures. So from this step, we are not anymore working with the 3D object, but we are looking at the 2D object so that we can see different position of the parts. Also, we can see also easily access visually to see the internal geometry of the part. So for this one, we need to go to the assembly navigator, turn off the or check out or gray out this box that I will show you in the software, and also start working and defining different operations based on this static wireframe. So you need to change the rendering style to the static wireframe. All right, next one is to define the starting and then the return points of the tool. So the point is that when the tool is selected in the operation ones, the tool will be brought from the turret or the home position directly to this point that is the pink point here. The color, the pink one. The tool will be directly come here as it is shown here direct, and after that then it will go through the different processes. So this is somehow the safe zone or safe plane of the starting position. We can also have the return position or clearance position into the same as this point, or we can define it separately, but I'm going to define it the same one. Also, we can define similarly a clearance plane. This value, for example, now is defined 13, but it really depends on your geometry and how do you want to do that based on different tools, for example, that they are going to be installed on your machine. But this is just to define a clearance plane. So these are to define the potential collision of your tool with your workpiece. After that, we need to also define another geometry that is called containment. And in here, we are defining the geometry as avoidance. So these are the typical vocabularies that you need to be working with, that defining geometry that is called containment, but however you need to define the avoidance, which means that to avoid the collision of the parts or the chunk itself as an avoidance. So these are the vocabularies that you should be remembering or practicing to remember when you are defining different operation on the software. And here, for example, here it's this defined minus 125. So from the 0 point of the workpiece, 125 millimeters backward. And this is how the axial ZM/XM, so the plane ZX on the machine, for defining where the chalk is. So it means that you have this much clearance from your final part to the position that the chalk is going to clamp the raw stock. And you have the distance between the axial orange axial line that you can see here, or axial plane, to the point that you have at the end of your part. So here is the zone that you have available for having extra place, so that you can take out the tools or you can actually cut off the parts. So therefore, at the end, our geometry would be having this kind of a setting. So we have defined the machine work coordinate system in the spindle. We have defined what is the workpiece. We have defined what is the turning workpiece or the blank. We have defined the avoidance and also containment, which is defining our spindle. Also, in the same setup section, you can also create all type of tools that you would like to use it in your software or in your operation list. This is somehow optional. You can either detect and define your tools before you go through the program creation, or you can create the program, or you can create the program on operation one by one, and each time that you need to have a tool, you can directly define the tool then. But for example, something that is obvious anyway, you would need for this kind of a part, spot drill, so you can already create it. And for example, maybe one approach to do that, that I would prefer to do that, is that I will assign the internal tools, for example, here, as you can see, the internal tools, like for example, drills or internal roughing, for example, tools, to the even number, and and then the outside diameter. So the external tool, for example, to the odd stations of the turret. So for example, here, spot drill are defined on number 2 and 4, and outside diameter profiling on the right-hand side, for example, is defined on number 5. Or if I have any grooving outside, I will again define it in number 7, for example. Just you need to make sure that you are not assigning one station number to the two different tools. Of course, the software might have detected, but then in case it doesn't, then you will be in trouble. So what you need to make sure is that first of all, each station is only dedicated for one specific tool. Second of all, it is preferable to use internal diameter tools to odd or even. So in this case, the internal one are assigned to the even number, so 2, 4, 6, and so on. And then the outside diameter tool to odd number, so 1, 3, 5, and so on. You need to make sure that you have enough room for in your turret for your tool. And if not, then you need to have an additional turret, for example, for those. Another point that you need to pay attention is that you should see that are you using any specific standard tools, or is it some company specific tools, for example. Sometimes in the library of the Siemens, you should be able to retrieve the tool. So for example, in the right hand side, we are retrieving the tool from a search results. We have search UGT, for example, from the library. But this might not be always the case, and you should be able to creating the tools. When you are creating the tools, you should be able to define as much as information that is needed for the software and for yourself to make sure that there wouldn't be any collision or any wrong values. These information contains the geometry of the components, even the holder of the component, which is a lot important, and what is the size of the general sizes of the dimensions, for example, so that the software can detect any undesired collision, for example. Another thing that you need to pay attention is that you are assigning a specific tool for a station number. So it means that after that the program is completely made and it is transferred to the machine will call those tools based on this station number. Therefore, it is very important that you are able to communicate this with the operator in the workshop floor. Or if you are operating yourself, you need to make sure that you are, for example, in this case, allocating outside diameter tool with a length of 80 to station 1. you need to put the spot drill on station 2. And station 3 should have the outside diameter with a length of 55 and so on. Otherwise, then there will be some collision and some troubles with your drilling, even though your program might have been work perfectly fine in the software, but not in practice. All right, before we go to the next step, which is the main program, I will now switch to the software and show you first the menus and how to define these steps. All right, so this is the shaft geometry that we're gonna work on it. I'm not sure if we're gonna finish the whole part or I'm going to just show you as much as possible just to learn and practice how does the operation need to be defined and how to troubleshoot the errors, for example. You can see that now I have a shaft here, which is a rather simple shaft. It has some internal structure. So there are two grooves here. For example, we could consider that there would be another thread, internal thread, for example, and there would be a hole or drill hole all the way to the whole part. And this is how the shaft look like. We have the form structure here, both internal and external diameter. In some of the cases, especially in terms of production of a same product, these kind of curves or form cutting, there might be some specific tools that the company manufactures so that you don't need to go through the whole curve by a normal tool, but just rather having a predefined form so that it will create this form, even if it is simple or complex component, and you can just manufacturing it by simple touch of the tool and your raw stock. But in this case, we are not gonna go through the defined form, so we are going to use a predefined simple geometry of the tool so that we can manufacturing it by any random shape. But for this one, we can see that we have two groups here. We have the threads that the size is here, for example. We have the drill here that we agree that we can first make the spot drill. Then depending on what is the diameter of this one, we can decide about having interpass, or let's say first making a smaller drill and then making a bigger drill to reach finally our final desired diameter that we are looking for here, or directly making the final drill after the spin, that after the first drill that we have. So internally we have two grooves here. We could have one thread, but it's not. And also internally there is also a curve. Maybe it's better that I can show you in here on this sketch file that I can show you later, so that you can see what is the structure also inside. So I was saying that you can either import this file. So for example, this is an existing component. We are importing it, and I can see from this tree here that it is made by the revolve, and then the x-axis or the axis of the component is equal to x. So perhaps it would be fine when I'm going to go through the definition of the operation. If not, you should be able to also sketch it yourself, the part like that. And after this, making the sketch, so pay attention that I made the sketch already in ZX axis, so that ZX plane, so that the axis would be on X, for example. Then after that, the sketch is finished. Then here I will be revolving this closed sketch. Revolve of the closed sketch. I will be running the command here, closing my curve. Then after that, I will select the point here, and then also the vector, which is this one. And now I have my curve here. And if I want to have the, let's say, the thread, I also should be able to find it here. If you are not able to find your command that you are looking for here, especially for those people who are familiar with some CAD/CAM software, but you are not work with the Siemens NX itself, for me even it sometimes become confusing since there might be some on and off options here. I might not be able to quickly find the things that I'm looking for. There is always a chance to write uh, the command that you are looking for here. So for example, I'm going to define a command, for example, here, and I'm going to define it, for example, the detailed one, or I can define actually thread from manually defining a thread or defining a thread table. I will not now complete this section because it might take some time. And this software seems to be a bit slow, but for example, this is the diameter 100, and this would be the correct size. Let's go back to the model that we already have. So the first step was to measure the component, just to make sure that the diameter are the same that we are looking for. And in case we need to define a raw stock material, we would be able to define those ones. So here, again, if you are trouble to finding the commands that you are looking for, I'm going to try to measure. First thing that I'm interested in for the matter of defining my raw stock is that to see that what is the diameter of this one. So here I have the radius of 50, so diameter of 100. I have the biggest diameter here. So for your information, just to repeat this one, I just type here measure, and then I can define also the distance here. So I can see that 145 is my sizes. So at this step, you should be also checking with the raw stock material that are available in your workshop, for example, and define based on those ones. So now we have the 100, but it might be possible that we don't have any diameter of 100, for example, in your workshop. It might be that 150 is the next size that is available. So now we have done this measurement, and I think now we are good to go. I will just explain you a little bit about the different menus here, and then we will start to define the setup of the program. So here now we are in the part navigator, so we can see all the different steps that we have taken to create these parts. After that, we need to go through the machining. So we just click File, New, and then I will wait so that this window will be open. Now I have the manufacturing, and I want to go through the turning essentials. I would be able to choose the location for my part. So for example, I can see that, well, this is the file. Then you can name your part. So for example, tutorial, lathe machining, and part 1. And now we are entering to the module of machine. You can easily detect it since the color is a little bit changing, and we are now in this module. So here, if you see, we have added one new navigator, which is, we call it Operation Navigator. Sorry that the icon is a bit smaller, but you can increase the size if you want. But this is the Operation Navigator. We're going to use this Operation Navigator quite a lot, and only one time we are going to go through the Assembly Navigator. And in case in between you needed to change something, you have the Part Navigator here. So you can easily go through the different navigator and go to the different sections. So I go back to the Operation Navigator. Operation Navigator itself has 4 main tabs. The first one is the Program Order View. Program Order View is now currently empty, but this is something that will be filled up a little bit, and we will come back to it later on. Then we have the Machine Tool View. So this is our turret. Currently, it is automatically predefined Station 1 for a outside diameter tool, which is now colliding. It is now inside here. And then, well, this doesn't mean that necessarily it is colliding. It is just the visualization to shows, because now we don't have any offsets or nothing is being defined. And also another outside diameter, for example, length 55 in station 3. So I can already see that outside diameter tool is defined on the odd number. So if I were going to define any internal tool, I will define it on the even number from now. So this is the tool that will be gradually completed, and at the end we're gonna have the full list of the tools that are available here to follow and make sure that the tools are complete. In the next step, we go to the geometry view. In the geometry view is the steps that we're gonna now try to define the parts, blanks, and any avoidance and so on. We come back to it. And we have the machining method view. So machining method view are the operations that we are defining. The roughing, finishing, drilling, groove, thread, and so on. So we go back now to the geometry view. In the geometry view, I can just double click on the spindle, machine coordinate system spindle, and this is the first thing you need to check very carefully. Double click again. You need to check this very carefully. That first of all, the coordinate point is at the bottom of the part, exactly in the center, and the plane here, it's you can see the configuration of the plane and also the Z of the machine itself. The Z of the machine should be the same than the axles of your component and also this plane. So if this plane is for some reason parallel to this surface or to the facing of your part, the face of your part, this is something that is going to be problematic, and you can simply try to rotate it by, for example, here. So this is now a wrong configuration. And in case you did something wrong and you want to cancel it, you can always cancel it. In this case, it was totally fine and I don't need to change anything, but I just wanted to show you how you can basically change. And if you change it and you see that there is still a problem, especially for your assignment, it means that you need to go back and perhaps remodel your part so that it would be in the same axis. So here, this is the ZX of the machine itself. So this is for me fine and I don't need to do anything and I just click OK. Next, I will click on the plus sign and beside this machine coordinate system spindle. And now I have the workpiece. So here I double click again, and now I can define the workpiece. I will define the part itself. So for me, this is the part. I click OK. For those of you who have the part and the blank at this level, at this step, assembled on top of each other, so you might not be able to see the components since the blank side is the bigger one. So in those cases, that you need to define transparency for the component that you are looking for. So this is another example, for example, here. So you can see that there is a blank and also the part itself. So then you have defined the transparency of these parts. And then if you want to select the part that is behind this cylinder that is on top, you need to just wait, hold on for a second, and then you can see these three dots appearing on the bottom of the cursor. You click on, and now you have the chance to select different features of your design. Either it is your solid body on the top, solid body on below, or even different faces, for example. This is just for your side information of how to coordinate the actions with the software itself. But in this case, it's rather simple. I just click the part itself. This is my part. I have already defined that. So I can see that now there is an eye here. I can click display and I make sure that it is already defined and it is correct. Now I specify blank. For those of you who define the blank already in the assembly or in the CAD file, so you just need to go and click the cylinder. But in this case, I need to create the blank. I will create the blank, and instead of now selecting an existing geometry, I have a different one. I can have a bounding block, or in this case, I have a bounding cylinder. And here is the size of your raw stock. that you need to first make sure that it is available in your workshop. If not, you will choose a value, but this is the value that you need to be communicating with your machinists, for example, that this is the size of your raw stock, 110 in millimeter, and then also 155. And now I can go to this view. And then next thing that we need to define is about these distances. This distance plus is the distance after your part from this axis. So this is something that I will define. For example, 3 millimeter is enough that I will have a facing there. And then the rest 7 millimeter would be, for example, here, or I can see that maybe it's a little bit too little for clamping. So I will just increase the height here, for example, to 160. And then again, I will correct this value to be 3. And then now it's perhaps fine. And I will just consider this one as my raw stock. So this is something that you can change, for example. If not, you can put 170, but every time make sure that these values are finally the same. So now I have 22 millimeter for clamping, but of course, considering that I might actually define the cutting process automatically, and cutting tool might also take maybe 2-3 millimeter. So anyway, I have something like 2 centimeter, or let's say around 20 millimeter for clamping with the spindle, which should be okay. So finally, my diameter for the dimension of my raw stock is 110 in millimeter in diameter and 170 millimeter for height. All right, click here. We have defined now this one. And then we have the material to be selected. So for example, we can now just define it for carbon steel. If not, you have the list of other parameter material to be selected. And then you have also specify, you can also specify the chunk here in case you have already defined it as a geometry. But now I don't have a geometry, but I will define a containment so that the tool doesn't proceed after that. We will reach that point as well. So at this point, we are fine. We said okay, and then we have another plus sign, and now we are need to define the different geometry here. All right. Next is to opening the turning workpiece that we have the avoidance here, and here is the one that we need to define. What is the point that the tool starts to work, and what is the point to go to the home position? I double click on this one, and the first thing I need to define is about point from start. I can specify this with the exact values, for example, if I have, or I can just define a points here. So I just need to pay attention that there would be enough space axially and radially comparing to the tip of my raw stock. So somewhere here would be fine. And let's see if I have a better chance to define this maybe as a better value, even though it doesn't really matter. So I defined it now here. Then after that, I have the go to home point. I will select first to de-engage axially and then radially. So axial, radial. And then I will say that to define the same points. And now I have the points here. And then I can define also the geometry for the a plane that I can consider that this would be the plane that after that it would be for spindle. So I will just create a geometry here. Containment, yes. I will create the containment. So this is defining the axis that we are defining here on an axial plane so that there would be no overpass of the tool along the axis of the machine, since it would be reserved for the spindle. So then here, let's see, now I have, well, you can basically quickly check if this is the one that you are looking for. You don't need to necessarily think. and decide what to do. So this is not we are looking for. So I put it 1. So I know that now I'm not looking for radial one, I'm looking for axial one. And I'm going to define only one plane. So it's better to define it like that. So if the distance is 0, it is supposed that the spindle will be here. So you have this many space for spindle clamping, which is fine. But then again, it's a little bit too much in that sense that you cannot finally create your part because there would be collision here. So if you don't want to put any cutout, perhaps then this would be, for example, that much that you have 5 mm available. But if you want to put some cutout, for example, we can put, for example, let's say 15, or it's a bit too much, or 10, for example, and then you have enough parts to be clamped. But these are the things that you should be calculating and decide about it beforehand. Or if you just notice here, you should be also calculating that, okay, is this enough space for all the forces and manufacturing forces that you're gonna intend to to put on your manufacturing parts or not? Does the spindle able to bear these forces? If not, then you need to go and change something in your CAD file. But supposing that this is the value, I'll just click here. So now I have the avoidance, which is defined where does the tool is able to start and to go, and where does the tool is not able to go after this containment. Next, what we need to do is to change the way that we are viewing this part or rendering style. For that one, you need to first go inside the navigation pan, or here. So you go to the assembly, yes, here, assembly navigator. Then you gray out the model. Then you have actually the 2D version of your part itself. And now you need to right click, go through the rendering style, and choosing the wireframe with hidden with dimension on the edges. And sometimes it might be called the rendering style of static wireframe, for example. But now we have with dimension edges. Now I have this current view, and we are able to define this one. You could also define this one a bit sooner, so that when you were in the avoidance part, you could basically see it in this view, or in the containment, you could also see it in this view. All right. Now we are done by the initial setup. And then in the next video, I can define with you how to define the main program. Other than that, I can also a little bit also describe here. You can see already defining the tool, defining the geometry, and defining the operations. And you can see all type of operations here. So for example, if we are defining operations, we are first defining what type of operation we are looking for. And then we need to define in which program, what is the tool, what is the geometry, and what is the methods. And then we can call it a process. If not, you can also create the tool itself, for example. So we can already create a spot drill, for example, before we go to the next program, next video. So we are defining a spot drill for essential drilling. And then we can define the spot drill. Well, just to make sure we are defining it correctly, I can always check here with the tool itself. So I can see that tool station number 2 is empty, as it is also available here. I call it a spot drill. If I have many drills, for example, that there are only the matter of different. So for example, now this is a spot drill, but if not, if it was a drill, for example, I can say that, okay, what is the diameter? Just some text that it would be clear for you or your colleagues to be able to follow. But now spot drill, this is fine. And I'm creating a spot drill, for example, here. Now I have the dimensions of the spot drills to be able to define it here. So what is the diameter of a spot drill? what is the length of it, what is the flute size, and then I can also define the shanks, for example, here. So these are also important parameters that you need to define as realistically as possible. So best case scenario, you should ask your workshop members or your colleagues to see that what are the available tools there, and then define it, because these are the one that is finally defining if we have any collisions or not. So for example, this is my spot drill now. I don't define it for the sake of this tutorial so that we save time on the video. Now, supposing that we are defining the size of the tool holder and also the shanks and so on, and hoping that the values are correct, we can see that the tool number is 2, it is correct, and then you have some other information, or you could actually retrieve it from the library as well. So here you just need to say spot drill, and then you can see what is the size of the spot drill and so on. So for now, I'm now going to only create a tool spot drill like that, so that we have covered this one in this setup section, and we go through the next video. So for now, I have 3 tools. These 2 tools, 1 and 3, was already existing. The number 2, it was the one that we have created here, spot drill. And then in the next video, we're gonna go through the creating the main program and operation one by one.